Hello and welcome to a new chapter of mathematics on determinant. Today we shall be beginning this first lecture on determinant by the basic definition of determinant. After that we are going to discuss their types based on their orders. Later we shall evaluate the values of determinants of order 2 and 3. After that we are going to discuss two terms that are frequently used in determinant and are minors and cofactors of a determinant. And finally, we shall conclude the first lecture by determining the problems to determine the value of determinants of order 2 and 3. Starting with the basic definition of a determinant is a special kind of symbol which is used in almost every branch of mathematics to determine certain properties of systems of equations and functions. Now, next we come to classification of determinants on the basis of their orders. Here we are supposed to study determinants of two types, and those are determinant of second order and determinant of third order. So starting with determinant of second order, we consider any four elements, let's say A, B, C and D, arranged within two vertical bars consisting of two rows and two columns constitute a determinant of order 2. Now, in order to find the value or meaning or expansion of this determinant, we obtain the cross multiplication product, and its value is then given as AD minus BC. Here, the elements of this determinant of order 2 are A, B, C and D. The element A is said to be the leading element and the diagonal AD is said to be the leading diagonal. Now we consider two simultaneous equations. Let's say a1x plus b1y equal to 0. This equation is labeled as equation number 1, and second equation is a2x plus b2y equal to 0. This equation is being labeled as equation number 2. Now elimination of x and y gives us an expression of the form a1 b2 minus a2 b1 equal to 0. Now this expression in equation number 3 may be written in the determinant form as a1 b1 a2 b2. This implies that the determinant which has its element as a1 b1 a2 b2 can be written in the form as represented in equation number 3. Next we consider determinant of second order, in which the elements are represented in the form a11, a12, a21 and a22. Here the element residing in column 1 are a11 and a21, and in column 2 are a12 and a22. The elements in R1 are a11 and a12, and the elements in row 2, that is row R2, are a21 and a22. Now let's suppose a12. Here in a12, the first subscript, that is 1 here, represent the row, and the second subscript, that is 2 here, represent the column. That means this element lies in the first row and second column of the determinant. So the value of this determinant is equal to, by cross multiplying the diagonal elements, we have a11 a22 minus a12 a21 as the value or expansion of this determinant. Next we consider determinant of order 3. A determinant of order 3 consists of 3 rows and 3 columns, and thus it appears to a form as shown, consisting of row 1 having elements as a1 b1 c1, row 2 having elements as a2 b2 c2, and row 3 having elements as a3 b3 c3. Now, as is very much evident, this determinant consists of 3 rows and 3 columns, thus in total 9 elements. Similarly, A determinant of fourth order would be containing 4 rows and 4 columns and consequently would be having 16 elements, whereas a determinant of nth order would be containing n rows and n columns and therefore n square elements. Next we are going to determine the value of determinant of order 3. For this we are going to consider three simultaneous equations which are given as: the first equation is a1x plus b1y plus c1z equal to 0. a2x plus b2y plus c2z equal to 0 is labeled as second equation. And the third equation is a3x plus b3y plus c3z equal to 0. Now using second and third equations, we are going to find out the proportional values of x, y, and z by the use of cross multiplication method. In this method, what we do is, while finding out the value of proportional value of x, we are going to hide out the elements of x. Now in this example, while considering second and third equations, in order to find the proportional value of x, what we do is we are going to hide out the elements of x, which are a2 and a3, and by obtaining the difference between the cross multiplication products, which are b2 c3 minus b3 c2, we are going to find out the proportional value of x. Similarly, in order to find the value of y, we are going to put a negative sign, and in the similar way, by hiding out the elements of y, which are b2 and b3 in equation number 2 and 3 respectively, we are going to find out the cross multiplication product of the rest terms, which are the elements of x and z, and these values are a2 c3 minus a3 c2. Similarly, z can be written as, by hiding out the elements of z, that is c2 and c3, and using the elements of x and y, we have proportional value of z as a2 b3 minus b2 a3. Now these entire equation is substituted to a constant which is equal to k. Now in terms of this constant, this gives us x equal to k into b2c3 minus b3c2. Similarly, y is equal to k into c2a3 minus a2c3, and z can be written as k into a2b3 minus a3b2. Now we'll label these equations as, let's say, a, b, and c. Next we are going to substitute these values into equation number 1, and equation number 1 becomes a1 into b2c3 minus b3c2 minus b1 into c2a3 minus a2c3 minus c1 into a2b3 minus a3b2. This would be equal to 0, and this equation has been labeled as equation number 4. Now this equation number 4 can be written in the determinant form as the determinant with row 1 elements as a1 b1 c1, row 2 as a2 b2 c2, and row 3 as a3 b3 c3. This implies that the given determinant can be written in the form as shown in equation number 4. We can further break the right hand side of equation number 5 as a1 into determinant of b2 c2 b3 c3, similarly minus b1 into determinant of a2 c2 a3 c3 minus c1 into determinant of a2 b2 a3 b3. Now this signifies, and this shows how we can determine the values of determinants of order 3. Next we are going to discuss minors and cofactors. So starting with a minor of an element is a determinant that is left after removing the row and the column which intersect at that element and is of order less than that of the given determinant. Now we consider an example, a third order determinant having the values as a1 b1 c1 and a2 b2 c2 and third row is A3, B3, C3. Now in order to find the minor of the elements, let's say A1, now we are denoting the minor of A1 as A1. It would be obtained by removing the column containing A1 and removing the row containing A1. So minor of A1 would be obtained by the values of B2, C2 and B3, C3. Similarly, other elements minors can be found out. Next, we consider cofactor of an element of a determinant. By applying appropriate sign to the minor of an element, we can obtain its cofactor. Next, we are going to evaluate the determinant of a second order determinant whose elements are 1, minus 3, 4 and 2. Now in order to find out the determinant, which is given as delta or D, we are going to find the difference of the cross multiplication product, which is 1 into 2 minus of 4 into minus 3. This would give us 2 plus 12. This is equal to 14. That implies that the value of this second order determinant is 14. Next, we are going to consider a third order determinant whose value is to be found. For this, we are going to use the derived equations and we are going to expand the first. This would give us delta or determinant equal to 1 into minor of 1, which is 1 minus 3 and 2 minus 3 into determinant into minor of minus 3, which are 4 minus 1, 5 and 2 minus 2 into determinant into minor of minus 2, which is 4, 1, 5 and minus 3. This would give us 1 into 2 minus 3 into 8 plus 5 minus 2 into minus 12 minus 5. This would give us 1 into minus 1 minus 3 into 13 minus 2 into minus 17. This will give us a final result of minus 6. This implies that the value of this third order determinant is minus 6. This concludes our first lecture on determinant.